Okay, lesson 3.3, proving and applying the cosine law. So the sine law was all about finding a set. And if you had an angle and the side length opposite that angle, you could use the sine law. What if you don't have the angle and the side opposite? You need another tool to use, and the cosine law is another tool. So notice over here, my triangle is labeled the same. I've got big angle A across from its small side A. I've got big angle B across from its small side B, big angle C across from its small side C. So it's labeled the same. So as long as we are in an acute triangle, meaning none of the angles are above 90 degrees, here is the cosine law. And the basic cosine law is set up like this. A squared equals b squared plus c squared minus 2bc cos of A. Now this means take the side length of A and square it. It equals the side length of B squared plus the side length of C squared minus 2 times the length of B times the length of C cos A. What's really, really important in the cosine law is that you realize that this entire thing back here is all one thing. I want to highlight it for you. Let's see if we can find the highlighter there. I want to highlight it for you because this is one thing. One thing. You can't separate the parts, and you got to use your bedmass rules here. So if you use the cosine law, you got to remember that you would have to always multiply before you subtract. Okay, and this may make sense as we go through some examples if it doesn't make sense right now. But it's really important that you remember that that is one thing. Everything is being multiplied with each other. So it says, and these letters depend on which triangle you're talking about. So let's say you had a triangle DEF. Oops, big angle. Oh, sorry, big angle D. Let's try this again. So that would be a big angle D. Across would be small side D. Let's say this was big angle E. That would be side E, big angle F, small side F. So if you had different letters, your cosine law would just be set up a little different. So you could say that D squared equals E squared plus F squared minus 2EF cos of D. Okay, you could say E squared equals F squared plus D squared minus 2FD cos of E, and etc. So you always have this part and this part matching. Okay, notice in my other questions, I had A here, I had A here. B was here, B was there, etc. C and C. And then look, BC, BC, AC, AC, AB, AB. So it's always set up like that for the cosine law. So you manipulate the cosine law depending on what kind of triangle you have. So you can use the cosine law to solve a problem that can be modeled by an acute triangle when you know two sides and a contained angle, or if you know all three sides. So remember that the sine law was all about a set. Cosine law is all about this contained angle. Now, what's a contained angle? A contained angle is an angle that's in between two sides. Okay? So over here, for example, if I was talking about this angle here, I would not call this angle contained because I don't know this side. Okay, so this angle would only be contained if I knew the side length here and I knew the side length here. This angle would be contained if I knew this side and this side. But based on this picture, they've indicated here, they've indicated that from this picture, this check mark means I know this side length, this check mark means I know this side length, and this mark here means I know this angle. So this angle would be contained. Over here, I can use the cosine law because I know all three sides. So cosine law is all about the contained angle. Cos law, contained. Okay, so the second one, are you wondering? There's no contained angle. But there actually would be, because if you knew all three side lengths, you wouldn't be solving for a side length, you'd be solving for an angle. And this angle here would be contained because it's between this known side and this known side. This angle would be contained because it's between two known side lengths. Same, between two known side lengths. Okay? So this bottom summary part here says, when using the cosine law to determine an angle, you can substitute the known values first and then solve for the unknown angle, or you can rearrange the formula to solve for the cosine of an unknown angle and then substitute, evaluate. I'm not a big fan of this part. I'm not a big fan of rearranging the formula. I just like to use the cosine law as is and let algebra take care of that part. So let me go through some examples and you can see what I mean. Okay, so example, I'm not a fan of black, let's get blue. Determine the length of CB to the nearest centimeter. All right, so notice they're using two capital letters, CB, but CB is also known as small side A. Okay, so it's asking me to find A. So cosine law then needs to be set up for A. I've got B, over here is small side B, right here. And if this is angle C, this would be small side C. So because it's asking for A, set cosine law up for A. So I would say A squared equals B squared plus C squared minus 2BC cos of A. And remember what I told you. This is all one thing. It's 2 times B times C times the cos of A. So that has to be done first. Okay, change my color so you can see substitution. Now A is my unknown. I can't plug that in. That's what I want to find. So A squared equals B squared. Here's B. Okay, across from angle B, here's B. Looks like a 6, but it's a B. It's 22. So plug that in. I put it in a bracket just so you could see that I substituted it. Plus C squared. Okay, here's C because it's across from angle C. 36 squared minus 2 times B times C times the cos of angle A, 74. So A squared equals all of this. So let's simplify. A squared equals. All right, 22. So if you don't have your calculator, you can use the unknown. You can use our online calculator. 22, is there a squared button? There, 22 squared is 484. 22 squared, or 84, plus 36 squared. I'm going to use my calculator on my desk. 36 squared is 1,296. Does my pen work with me? 1,296 minus 2 times 22 times 36 times the cos of 74. 2 times 22 times 36 times the cos of 74, cos of 74. Enter, equals. All right, 436. I'm going to save quite a few decimals here, so I'm going to call it 436.609. 609. All right, so A squared equals 44 plus 1,296 minus 436.609. I'm going to do that on my calculator on my desk. 34 plus 1,296 minus 436.609. So I get 1,343.391. We want A. A is being squared. We have A squared equals this. To find A by itself, you will square root both sides. So take the square root 1343.391. And because it asked for the nearest centimeter, I have 36.65. Because it says to the nearest centimeter, I would say 37. So A is 37 centimeters. Let's see, does that make sense? Well, I only have one angle, so I can't really tell. Although, if this is 37 and this is 36, this angle here is going to be smaller than 74, but it's 73. Okay, I'm not going to calculate it, but now that I have a set, I could use the sine law to figure it out, but it will be very close to 74 degrees. Okay, so when you want to find a side length, you set up your cosine law for the side that you want to find. Example number 2 is we want to find an angle, which is a little bit different. We want to know angle A. Angle A is contained between these two known side lengths, so I can use the cosine law. Because I want to know A, I am again going to set up the cosine law for A. So you always set up the cosine law for whatever you need. So A squared equals B squared plus C squared minus 2BC cos of big A. Remember, these two always match, and you always set it up for whatever you need. If this is big angle A, this is small a, big B, small b. Oh, that looks better. That's a B, not a 6. If this is C, that's small c. Okay, I'm changing colors so you can see my substitution. Now, I want cos A. I'm going to highlight it on purpose because this one's going to be a little different. This is what I want to find. Right there. I like yellow better, but okay. Let's go back to my pen. Okay, so here's big angle A, there's small side A. That's what I plug in for A this time. So 14 squared equals B, 10 squared, plus C, 16 squared, minus 2B, C, cos A. This is what I'm trying to find here. I'm trying to find angle A. This is what I'm going to solve for. Remember, this entire thing is being multiplied together. So if I convert 14 squared 196 equals 100 plus 256 minus 2 times 10 times 16 times the cos of A. Well, I don't know what the cos of A is, but I can do 2 times 10 times 16. 2 times 10 is 20. 20 times 16 is like 2 times 16, so it's 320 cos of A. Okay, BEDMAS question now. I'm going to highlight this again so you really see. This is all one thing here. It's 320 times the cos of A. So what I got to do is isolate this. This is my unknown right here. A is my unknown. Oops, I'm going to pen. A is my unknown right here. So that's what has to be isolated. So this has to go away, and this has to go away. So I have 196 equals, I can add these two together, 356 minus 320 cos of A. This has to go. Subtract 356 from both sides. This negative is attached, so this stays as negative 320 cos of A. Over here, I have 196 divided by 356. No, subtract, sorry, 196 subtract 356 is negative 160. So 196 minus 356 is negative 160. This is my unknown, so I'm going to divide by negative 320. I'm dividing by negative 320 because it's the cos of A times negative 320. I want that to cancel, leaving my cos of A. If I divide the right side, I have to divide the left side. So negative 160 divided by negative 320 is positive 0.5. So I have the cos of A equals 0.5. If you want angle A, I'm going to have to find the inverse, cos negative 1 of 0.5. If I know the ratio, I ask my calculator, okay, the ratio is 0.5, what angle do I get? So on that scientific calculator, you know, second cos, no, let's clear, sorry, second cos of 0.5. And that's asking the calculator when the ratio is 0.5, what angle created it? 60-degree angle. So angle A is 60 degrees. Done. All right, so you're either going to be finding a side length, so set up the cosine law for your side, or you're going to be finding an angle and set up your cosine law for your angle. All right, good luck on your practice.